All right, so let's take a look at a percent yield problem. And really a percent yield, if you look at what the definition is of a percent yield, is we really want to know how well we did in lab. So let's just jump right into this first problem here. It says during a process in which 100 grams, I'm going to highlight that, 100 grams of sodium hydroxide are consumed. It says 70 grams of sodium hypochlorite are extracted, and it wants to know what the percent yield is. Now, in order to find percent yield, we do need to know the formula for percent yield, and I'll just write that up here in the corner here. It's our actual yield, and you might have this in your notes, divided by our theoretical yield times 100. So actual yield and theoretical yield. Now, our actual yield, that's what we actually get. That's what we actually get when we do the experiment. Our theoretical yield is what we should get. So in a perfect world, in a perfect lab setting, that's what we end up getting. So how do I do this? What do I do? Well, it tells me that when I run the experiment, I get 70 grams of sodium hypochlorite out. And so I want you to think about, well, is that my theoretical or is that my actual? Well, I ran the lab, and now I get 70 grams out of it. So that's my actual yield, 70 grams. So I know that right off the bat. That's my actual yield. This will usually be given to you in the problem. Our theoretical yield, well, that's what we need to calculate out. In a perfect world, what should I have gotten out? And to find that, we're going to use this 100 grams of sodium hydroxide. We know when we punch this in that 100 grams of sodium hydroxide gets used up. This is my starting point, 100 grams of NaOH. Now, could we plug that in, do a stoichiometry problem to find out just how much NaClO we should have gotten out? And hopefully the answer is yes. Yes, Mr. Rolfe, we can do that. 1 mole on the bottom. I think NaOH comes out to be about 40 grams. And I like to have labels so everything's nice and clean. We can see things canceling. Oh no, what did I do wrong? You should be stopping me. Oh, you can't because you're watching this. I want to make sure that the grams goes on the bottom because I want that unit to cancel out. So I'm going to have 40 grams on the bottom, not on top. And then 1 mole on top. And then we'll have, now we've got to go to our mole ratio. We've got to look at our coefficients, nothing there. So for every 2 moles NaOH, we have 1 mole NaClO. Last step. I think you know how to do this. Hopefully I set this up. No. NaClO, which weighs, boop, 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 punch that into my calculator, 74.5 grams. Stylus is not working for me here. So I punch that all into my calculator, and what I end up finding is that I get I get 93.125 grams of NaClO. Well, what do I do with that? Well, remember our equation here, our percent yield equation. We want to see just how much we get. Well, we already have the 70 grams here. 70 grams, that's how much we actually got. If we divide that, I didn't leave myself much space here, but we divide that by 93.125 grams, my theoretical, times that by 100, what do I get? I get about 75.2%. And we might be looking at that saying, well, we got a C on the lab. Well, not necessarily. 75% might be really good, 75% might be really bad. In the business world, you think about pharmaceuticals, they have a really low percentage, a very low percent yield. So, if you get 40% and your competitor can only produce 30%, hey, you're looking pretty good. You're going to be able to produce that drug if you're working for a pharmaceutical company for a lot less money, and you're going to have more profits, your bosses are going to love you, and you're going to get a promotion. So hopefully this helps you with percent yield. Let me know if you have any problems or questions.